Today I want to do something different. Instead of quickly introducing a topic and then getting straight into a practice problem where we do some math, I want to take this video to solely introduce a concept, and then we'll follow this up with some practice videos afterwards, right? So as you could see on the middle of your screen, we're doing minimum and maximum values. Now, if you just think for a second, that doesn't sound too hard, right? If I asked you, where does the function take on a minimum value and a maximum value? I'm guessing that most of you would say, okay, well, it looks like right here, we're taking on a minimum value, right? That looks like the lowest spot of the graph. And then it looks like right about here, we're taking on a maximum value, right? Somewhere in that area. Okay, so you would be correct to say that. We would say that at these points, whatever points they may be, we'll call them right here let me draw like a little dotted line. We'll call this x1, right? And then right at the beginning of the graph, we'll call that x naught. That's what that little zero is. It's x naught. We'll say at x naught, we have an absolute minimum value, right? There is no other value on that graph that is going to be less than the value right there. That is the absolute minimum. And then at x1, right, we have our absolute maximum, right? At that point, there is no other point on the graph where we will have a value greater than what we're given at x1, right? So we have an absolute minimum right here and an absolute maximum right here. But if you look at our graph a little harder, you notice we still have some bumps and curves every now and again, right? We have one right about here, right? That looks like a peak. Right here we've got like a little valley, and then right here we have another valley, right? And if we had just narrowed our field of vision, right? Say if we just looked from right here, you can see the little teal dotted lines, right? If we look right here, say that's our entire graph, then it looks like we have a maximum value right there, right? If that is our only field of vision, then that looks like that is the highest point on the graph. We're going from an increasing slope right to where a critical point should be. And then on the right side of that, we're going to a decreasing slope, right? And that would be a maximum value, right? We're going from increasing to decreasing, right? So right here, although that this is not the absolute maximum value, what we would do is we would call this a relative maximum value because we have some x, right? We'll call this here. We're going to call this x right here. We'll call it x2, right? And so we have x2, and on some interval that we've closed in, right? Let's say we have for x2, right? We have our value f of x2, and we're on some interval that we narrowed down. We'll just call it from a to b, right? On that interval from a to b, our x2 has a greater value than any other x. So that is going to be our relative maximum, right? And let's look at our other little valleys that we have left, right? If we do the exact same thing, if we narrow our field of vision, right? Just a little bit to the left and right of that point, then we have a relative minimum at that point, right? I'm kind of running out of space to write down all these words and keep it legible. So we have a relative minimum right here. And then again, if we narrow our field of vision to just right here, it looks like we have a minimum value. So we'll call that our relative min. Now, it also turns out that absolute max and mins can also be relative max and mins, because if we look at our absolute max, right, we just narrow it down again, we look to the left and right of it, we'll say, yep, that's a maximum right there. So not only is that an absolute max, we also have a relative max at that point. Now, if you notice, every time we looked for a relative value, we're looking to the left and right of that, right? So you might want to look at where we have x naught and say, oh, that's our absolute min. Well, it can also be a relative minimum. But here's the thing. That's the end point we have. We can't check the left side of it, right? We're restricted by what we're given. We can only see the right side. So for that fact, we don't have a relative minimum at that value, right? Does that make any sense, right? So we can't look to the left and right of it, so it's only an absolute min. At our absolute max, however, right here, we can see both to the left and to the right of it, so we can test and see that that is a relative minimum value. Now, we're eyeballing it, right? We want to know where these actual points come from. Now, in a future video, what we're going to do is we're going to find these critical points, right? We're going to find the first derivative and set it equal to 0. And then we're going to test the left and right sides to see, all right, is our slope increasing? Is our slope decreasing? And figure out where we have these relative and absolute minimum and maximum values. If you watched to the end of this video, I really appreciate it more than any other video since this is just a conceptual video. It means a lot to me. Thank you, and I hope you learned something.